Hello everyone. Welcome to the video lecture series on complex integration. I'm Mayur Gohil. Now in this video lecture we see altogether a different type of parameterization or type of integral solving. So using complex integration. So let us see how to go about this. So again over here the information that is given to us is almost similar to that was given to in the previous question. But now there is no evident way of x and y given. It's not on the face value. We are not given the x and y functions over here, but instead we have been given directly the value for z of t in okay, that is the z in terms of t, that is t plus it square. Okay, so let us see how to calculate this, and the limits that are given for t are in the interval format. Never mind, let us see how to go about this. So what we do over here, so our step number one will be directly attacking dz. So step one is find dz, and that is very straightforward over here because we have been given z of t, right? That can be uh, easy for us. So that is z of t is nothing but z. Okay, so t plus it square, and therefore if I want to find dz by dt, I can now calculate it very easily. That would be 1 plus 2it. Okay, therefore I get dz equals to 1 plus 2it dt. Done. So I am here ready with my dz. Now we need to calculate the value for the function in terms of the variable t, because it's the only variable over here now. So let us see simplifying function. So step number 2 would go for finding f of z in terms of t. So let us see how to do this. This is again quite straightforward. We have been given f of z is equals to 3z square minus 2z. Okay, so you substitute the curve over here. So that is z of t, which is we have taken z equal to t plus it square. You substitute it over here, so you will get 3 times t plus it square, the whole square. Just so here you will get 3 plus it square, the whole square, minus 2 times t plus it square. Now you expand it, so it is 3 times t square minus 2, plus of 2it cube minus of t raised to 4 minus 2 times t minus 2it square. Okay. Now we simplify this a bit further and collect the real and imaginary part. So what do we get is 3t square plus 6it cube minus 3t raised to 4 minus 2t minus 2it square. So this will give me 3t square minus 3t raised to 4 minus 2t plus I times 60 cube minus 2t square. So this is the second thing that we get. Okay, now we simplify the integral, like we go for solving of the integral now. So step number 3 over here is solve the solve integral. That's very evident now. So we will just plug up the values that are there. So I, therefore I equal to integral c f of z dz. We have found the value of f of z over here, that is 3t square minus 3t raised to 4 minus 2t plus I times 6t cube minus 2t square. Okay, this is the whole function, but dz is now already with 1 plus 2it, right? 1 plus 2it dt, and the value for t for the limits is going to be 0 to 1, because we can see t belongs in the interval 0 comma 1, so it is t going from 0 to 1. Okay, I'll just write 1 in this manner so for clarity. Okay, so we will now need to integrate. Before integration, we will now need to go for the simplification of the function a bit further, because we can see that there is this multiplication of two complex numbers over here, or two terms is possible. So let us go for that. Therefore I equal to, here you put I, it would be better, I equal to, so it will give you integral 3t square minus 3t raised to 4 minus 2t plus I times, it will be 6t cube minus 2t square. Okay, and then there is yeah, now see, there is again I is there, so the first term comes as it is, okay, because it is 1. Now it is I am keeping outside, and 2t I am multiplying over here into each of the terms, so it is 2, so it is 6t cube. Okay, 2t multiplied to this is going to be minus of 6t raised to 5. Then 2t multiplied to this is going to be minus of 4t square. Okay, now this 2it getting multiplied, so I becomes this thing I square, and that gives you minus sign, and then there is 2t getting multiplied inside. Okay, so it is going to give you 2 into 2t into 6t cube, so 2 into 6 is 12 t raised to 4. Okay, then minus of 2t into 2t square, that is going to be 4t cube dt, 0 to 1. Okay, now let us complete up this, and I think there is some simplification possible a bit, but yeah, some additions and subtractions are possible. So let us do that also, because that will ease out our integration calculation. So integral 0 to 1. Now you observe here, I'll highlight it with this let's say orange color. 3t square is here, okay, and 3t square is here, and there is no square term here. Okay, let it be, then that's not an issue, so we'll just go away with minus 3t for, yeah, yeah, so minus 3t raised to 4 and minus 12t raised to 4, that will give me minus of 15t raised to 4, so that will simplify a bit further. So I have first term here as 3t square, that as it is, minus of 15t raised to 4, that is good. Again I see there is minus 2t is there, and here there is plus of 4t cube. No issue, that will remain as it is. Minus of 2t and plus of 4t will remain as it is, 4t cube. Okay, so no problem with that. So our real part has been collected together. Okay, now here we see with the imaginary part there is some more simplification possible. So this 60 cube and this 60 cube together will add up to 12t cube. Okay, minus of this 2t square and minus of 4t square will give me minus of 60 square. Okay, so that is minus of 60 square, and then there is only this term left out, so this is gone and this term is merged together. So what about this one? Minus of 60 raised to 5, so that remains as minus of 60 raised to 5 alone. Okay, so let us see over here 3t square when we had multiplied it. Yeah, that remains as it is. Okay, so we have got our imaginary part and the real part of the function. So let us now just integrate it. No, not with dz, it's dt. Sorry, it will be dt. So now let's integrate it quickly. So what do I get on integration? I'll write here. Therefore I. Now you can do over here in your calculator if you are allowed. I'll just do the manual way because to have the feel of the whole concept. So it is t cube over here. It is 5t raised to, it is um, yeah, it is 3t raised to 5. Here it is t square. Here it is going to be t raised to 4, then plus I times, here it is going to be 4t raised to, no, not 4, it will be 3t raised to 4. Okay, so 3t raised to 4, here it will be 2t cube, and here it will be t raised to 6. Kind of a nice suitable answer generally which students are used to. So yeah, we will just substitute here, and therefore I equal to 1 minus 3 minus 1 plus 1 plus I times 3 minus 2 minus 1, and when you substitute the lower limit you will get 0 from each of the terms, and plus I times again 0, so that's not an issue. We'll just get it from the real part, our answer, not the real, the first upper limit when we substituted. So here we get it's going to be minus 1 plus 1 cancels, and here it's minus 2. Here it is 3 minus 2 is 1, and 1 minus 1 is 0. Oh, great. So our answer is minus 2. So this is our final answer. Okay. So now in this question, what was the learning that we understand is that when the parameterization is there, most of the time the limits are given to us. Okay, and another important thing is that you can immediately start finding dz. Okay, when the function is given directly in terms of t, so you need not worry about finding x and y and everything. You just find dz, that will become dz by dt. In that case the formula will be there as opposed to the ordinary way of doing. Okay, so dz is equals to you can directly find in terms of t from the relationship which is given to us. Later on, simplify the function and solve the integral. Again over here, just make a note that if we can simplify this function till here, okay, so till here, then the integral steps, two steps could have been reduced. These two steps could have been omitted and you could have got your final answer. So this is if you're using calculator. So this is all about the parameterization of the integration, parameterization type of complex integration. So you can try these kind of problems. So if you have understood the concept over here, please hit like button, share it with your friends and uh, your colleagues, those who find it useful. And till then, keep solving good amount of mathematics. I'll sign off. Thank you for watching the video.